Hello, everybody. Welcome to Android Study Jams 2022. It's great to be here with all of you, and it's going to be a couple of interesting sessions we have for you all throughout the course of these 3 days. I appreciate all of you joining in. So I'm going to talk a little about Android Study Jams before I begin with the sessions. Right. So what Android Study Jams actually is what I mean. We form study groups, which at the moment is all of you and me together. And what we do is I facilitate content about how you build apps and about a few other concepts related to Android app development. And you use these concepts to create basic apps and then scale them up as you progress through the courses. Right. I mean, when I was about in first year of college, the only thing I knew about Android apps was how you install APKs. So it's pretty cool that all of you are, I mean, everybody is learning about Android app development at this point. I'm gonna get started with the sessions. So I'm gonna start presenting my screen. Give me a minute, please. All right. So I hope all of you can see my screen. All right. Pulling up the PPT in a second. All right. So beginning with our first session where I'm going to be guiding all of you through Kotlin and Android basics. Kotlin is the official language for Android app development from a couple of past years. And I'm going to be guiding you through a few basics of the language as we progress. Right, so here are a few learning objectives that all of us would be completing through this entire course. So setting up Android Studio is something that, setting up Android Studio is something that all of you would have done, I presume. That would be one of the most important steps for us to get on with the session, as that would be our main point of contact to how you would build Android apps. Yeah, right. Now, the next learning objective that we're going to progress now would be learning the basics of Kotlin programming language. I'm going to get to that in a couple of minutes. Then I would guide you through how you build your first Android app and run it either on your phone or on something you called an Android virtual device, which runs on your laptop. And finally, throughout the course of these 3 sessions, we're going to be learning new concepts and adding them to the app that we already built in the beginning. So that way, we'll be discovering, when the set of concepts or the set of functionalities you can add to your app and how much you can achieve by doing so. Right. A couple of prerequisites: you would need a computer, an internet connection just in case you don't have Android Studio installed, right? And also you would need it to install a couple of codes for a sample app that we have. And also you might either want to get an Android device and connect it to your laptop via USB cable so that you can run your apps on your device. Or you can, as I said, you could run it on an Android virtual device, which I'll be guiding you through in a couple of minutes. All right. So the first topic for today would be Kotlin basics. And before I get started with that, I would like to guide you through what Google offers how Google helps us learn Android app development. So Google offers a course called Android Basics in Kotlin, where you have about 6 units where they teach you all the concepts about Android app development as well as Kotlin, how you integrate them into your app. And they also have a couple of what you call code labs where they give you hands-on practice on how you implement those features into your app, right? So this is an example of what you would find on Google's website. Uh, Kotlin Basics for Android is what the course is called. I'll be showing that to you in a couple of minutes. Now, every unit has a pathway. I mean, not one pathway, has multiple pathways, right? And each pathway each pathway consists of, you see several topics. A few of them might be videos, then you have something called code labs, which I just mentioned. And then you also have quizzes at the end of each unit at the end of each unit to help you, get accustomed to what you learned and test out your knowledge. And after you complete each unit, you're going to earn a couple of badges, and that helps you build your developer profile, which I'm going to be showing you again in a couple of minutes. So as you build along, as you learn along, the course, you would earn several badges, and you can, showcase them on your developer profile. Right. So before I continue, I'm going to just pull up a browser window and show you the Kotlin course. Right, so this is the course. You might want to create a developer profile for yourself before you get started with. Now you would see there are several units. You click on explore, you would see several pathways. Now each pathway would have a couple of activities. They might be videos, they might be code labs. You can just pull up one code lab to show you what it looks like. They would guide you through each and every step you would need to create or add a functionality to your app, right? They have everything sorted out properly. And at the end of every unit, you will earn a couple of badges, which will be added to your developer profile. Right. So getting back to the PPT. Now, what we're going to cover in the first session, as I mentioned, is first we're going to talk about Kotlin, and I'm going to guide you through a few basic concepts that you might need to, just know more about Kotlin, as well as you would use them as you build up apps. I'm going to come to this in a minute. This is what we call the Kotlin playground. Basically, you can run Kotlin on your browser without having to install any kind of IDE. I'm going to show that to you. Now we're going to next progress to Android Studio. That's going to be your official IDE on how you create Android apps. You might have heard of IntelliJ IDEA. That was what we used to create Android apps before, but now this is an official collaboration between Google and IntelliJ. So this is what you're going to be using to create all your apps. This is what I was talking about. It's called an Android virtual device, or what you do is you emulate a smartphone on your system, and that helps you run your apps, test out your apps, and several other things. We're also going to be talking about user interfaces and how you create different layouts, different views. Moving ahead, as I was saying, different layouts and views. I'm going to be covering to this at the end of the session. Right, different views again. You don't have to worry too much about this right now, but when I get to it, I'll make sure all of you understand. Right, getting started with Kotlin. So, yep. At Google I/O, many of you might have heard of that. So in 2017, Google announced that Kotlin would be their language for Android developers. And there are a few features of Kotlin that I've mentioned here. Kotlin is open sourced. That's one of the most notable strengths about a language, that it's open sourced. Supported by Google, of course. And then you have 100% interoperability with Java, which means that all existing Java frameworks can be used with Kotlin, as well as I'll show you in Android Studio that say you used to typing code in Java, so you can in fact convert the entire code to Kotlin by just a few clicks and nothing else. Also, Kotlin is, I would say, more efficient than Java because it removes a large amount of boilerplate code. what boilerplate code is say a set of lines of code that you would have to repeat again and again, right? So it removes the need for boilerplate code. And one more notable strength would be that Kotlin has both object-oriented as well as functional language constructs, whereas Java only has object-oriented. So that would help us, these two programming paradigms would help us develop, say, better apps. And also, null safety is one of the most notable features again. I would show you what null safety is a little bit later into the session. But null safety is one. I mean, I would say that Java didn't completely support null safety, but Kotlin has it covered throughout. Right. So moving ahead. Now here's a little difference between Kotlin and Java. Of course, you have a lot more, but I put down a few notable ones. Yeah, so the first thing, as I mentioned, Kotlin would have both object-oriented and functional programming constructs, whereas Java is only object-oriented. Now, Kotlin allows you to create something we call an extension function. So say you create a class, right? I'm going to be showing an example of this later on, but just to mention it at the moment, say you create a class somewhere in your program, and say you want to add a function to the class later on. So what you would just do is say your class is called A. So A dot function, and then you define that in your say main function, right? So I mean, most of the programming languages don't allow you to do that. You would have to include all the functions inside your class, that way. Whereas Java does not offer any extension functions. Now, Kotlin does not require variable data type specifications. So you wouldn't need to, specifically declare something as an int or a string. It's gonna be able to detect it by itself, but it's of course advisable to, specify it where you think it might be needed. But yeah, that's one other notable thing. Also, Kotlin does not require semicolons. I mean, that's a relief. It does not need semicolons, whereas again, Java does need semicolons, right? Moving ahead. Yeah, so this is what I was talking about. You can run Kotlin on your browser. So all you would have to do for that is pull up a window, and you would have to you can type in Kotlin lang. Yeah, and that was the first link that comes in, right? So again, all kinds of Kotlin code can be run here, and I'm going to be guiding you through different Kotlin concepts here in a moment. Right. So we're going to be starting off with Kotlin concepts now, and the first set of concepts that I would talk about is what you see on the screen here is your main function, right? So if you're used to C or C++, you would know that your program needs something that you call a main function. So anything that you have in your main function gets run automatically when you click on the run button. Right, so I'm going to be talking about functions in a moment. So what you need to know right now is this is your main function that I wouldn't say is needed for every program, because when we come to Android apps, there'll be a different sort of thing for that. You wouldn't need main functions there. But right now, I would say, yeah, you would need it for most of your programs. Right, so what you see inside the main function here, again, sorry, I forgot to mention, but if you have any doubts, please keep them rolling in the live chat, and I'll answer them in the middle of a session where we would have a small break. So I would answer all the questions then, but please feel free to keep on asking any questions you might have, and I'll try my best to answer all of them. All right. Getting back here, as I mentioned, the main function, and inside that we have what you see is a print statement. This is how you have a print statement in Kotlin. Print ln, which stands for print line, and whatever's inside codes gets printed. I mean, if you know Python, which most of you might, so you're going to see that I wouldn't say the functions are similar, but different types of data type. I mean, different types of. You would see that you have lists, you have arrays, and you have again sets, you have dictionaries, which are very similar to what you have in Python. And again, the code is very readable, so most of you will be just able to understand what's happening by looking into the code and reading out. Right, so starting off again, as I said, println would be used to print a line. So when I run this, you would see it prints hello world. Now you have another function to print, which is called just print. So if I would show you the difference between both, say you type in this, and I have a println. You would see that print does not have a line break between, I mean, line break afterwards being printed, but println, as you could see in the beginning, has a line break. So that's the only difference between both. Now, moving on to a few more things about print. Again, this would be pretty similar to what you might know from any of the languages that you already know, Python, C++, C, Java, anything. So you want to give a line break. You have your standard /n, which allows you to give a line break. Say you want to give a tab space. You have your /e. And yep, all of that is going to be pretty similar to most of your languages. Now, comments can be given by double slash. Yeah, that's your single line command. As multi-line command would be a little different from what you know in other languages. So what you would have is this. Sorry, this, yeah. Command. You would have to close it with this, right? Now, I'm gonna move on to different data types. So as I said, they're going to be mostly similar to most of your data types in Python. So you have a data type called string, right? That's one of the data types. Then you have something called int. Then you have arrays. So you can have an array of strings, which you specify by array string. You have array of integers, say, so you specify them by typing it out this way. You also have lists, sets, and dictionaries, which I'll get to in a moment. And then you also have something called an int range, which is just a range of numbers. Yeah, int range. Now, if you would see that this wouldn't be called camel case exactly. So camel case is something that you use to name, say, functions, classes, anything in Kotlin or Java must be named with camel case. Camel cases typically say something like this, but for data types, you have something called upper camel case. So which has both the starting letter as well as the one between and caps. Whereas camel case would be something like this, but that isn't a valid data type, right? So I'm gonna comment this line out. Okay, next I'm gonna be moving on to variables, right? So you might know what you call constant variables. Sorry, no. I mean, you might know something that you call, you have a prefix that you add to most variable declaration called const if you've studied C or C++, even in Python. But so what const does is it does not allow you to change the value of that data, of that variable throughout. Whereas normal variables, as the name goes, you, of course, would end up changing the values throughout. So I'll declare a variable with the keyword var, say a equals to 5. Now, as I said, you wouldn't need to mention the data type. Sorry, you would need to mention the data type of the variable. But if you do want to, cases that you might think you need, so what you would do is add a colon and say int equals to 5. Right? So that's how you declare a variable. Now, say you want to have something which I said you call a constant. So what you would do for that is you would use the keyword called val, right? So this declares a constant, and say I would say b equals to 5. Now this value cannot be changed throughout the program lifecycle. Again, you have similar rules for declaring a constant. You might, if you need to include data type, you would just do it the same way above. So you want to declare a constant string, so str string equals to Android, right? So that's pretty much about variable declarations. Also, you would see as we move along in the course, you would see when we build up apps, we use a keyword called late in it during variable declarations. So what this does is it initializes the variable without declaring it. I'm sorry, it declares the variable without initializing it. So this can be used, say, in apps where you might just want to create the variable in the beginning, but give it a value later when your app runs. So that's late in it. Again, the variable declaration follows a similar pattern. Right, now moving on to how you would print variables, right? So if I want to print the value of a variable, I would do println the value of a is, what you would have to do is use a dollar, then say a, right? So run this code. Sorry, 1 second. Yeah, I've declared a twice. Never mind. See. I'm going to show you this later when you pull up an Android app. 1 second. Oh, sorry, the wrong line. Right, so you would see the value of a has been printed here. Now, so as I said, what you do for printing out the value of variables is you use a dollar and you use a. Now, say you have a property of a class like a dot something. So in those cases, you just might want to include your variable within curly braces. So this is going to give you the same output, but you would see a difference when you have classes and you have multiple properties. Your property names are big, so these would come into play at that point of time. Right. Now, moving ahead. Okay, now I'm going to talk about what I mentioned before, lists, sets, and dictionaries. Right, so if you know Python, you would know what a list is, and it's pretty similar in Kotlin as well. How you create a list in Kotlin is a little different. So say I want to create a list called numbers. Now, you have two types of lists. I'll come to that, but this is how you create a list. You use the list of method, and then you say want to create a list of numbers, integers. So I would do 5. This creates a list of numbers. Now, as I mentioned, you have two different types of lists. One is called a mutable list, another one is called an immutable list. So a mutable list is a list where you can change the values. Change the values in the sense you can add on more values to the list after you've created the list, or you can also remove values, you can modify values, you can do all of that. Whereas an immutable list is one where you cannot do anything once the list is created. So immutable list is what I've created here. So once this is being created, you can't modify any of the contents of the list, right? All right, now you have a couple of functions that you can use with most data types in Kotlin. So I'm going to be guiding you through all of that. All right. So say I wanna, first of all, we'll print out the list to just see, okay, numbers. So see, yeah, that's our list out there. Now, say I wanna maybe check if a particular element is present in the list, right? So what I would do is numbers dot contains, this is the function, and say I want to check if the number 6 is present. So this would return a Boolean value, a true or a false. So you would see false because 7 is not present in the list, right? 6 is not present in the list, sorry. And then say if I have a number that is present in the list, so it should show up as true. Yep, you see it shows up as true there. Now, right, so now you also have a couple of other functions, right? So say you want to sort the list. You can, of course, create your own functions based on how you would like to sort the list. But on a general note, you have a sorting function. So numbers dot sorted. Now this would make a difference because our list is already sorted. But I would create another list. Say list of 154. So if I do this and if I do sorted, you would see the list get sorted in the ascending order by default, as you see in the end, right? Now we also have a function called size, right? So it prints the size of your list. I'm going to be running all of this together, so I'll write down the rest of the functions as well. Now also you have, say you would like to sort the list in the reverse order. So you would do num dot reversed, which would sort your list in the reversed order. And also you have two other functions to print the first element and the last element in your list. So say dot first would print the first element in your list, and this and the last element in your list, right? So running all of this together. I'm sorry, this shouldn't be this way. Yep. Right. So if you would see, we have a sorted list in ascending order. We have the size of our list. Now we have this list again. We have our first element and we have our last element based on the most current version of the list, right? And finally, if you want to access individual elements of the list, so you would do something like and let's take out the first list, numbers of 1, send that out. That would print the first element of the list, right? I mean, sorry, the index would be 0. So this prints out. Yep, you see it prints out the first element of the list, which is 1. Okay, that mostly wraps up immutable lists. Now, as I mentioned, you have another type of list which is called mutable list where you can edit the values or add in more values after you've created a list. So for that, I would say let's take up list. Again, camel case would be appreciated. Right, so the function that you use to create a mutable list would be called mutable list of. Again, the same way, say I create list of integers. We'll print the list out. Right, so you see our mutable list is here. Now on the surface, it looks pretty similar to a immutable list, but now you see a couple of functions that are different. You of course have these set of functions in the immutable list as well, but what's different in a mutable list is a function called add. So say mutable list add, which allows us to add elements to the list even after it has been created. So if you run this, you would see, okay, sorry, I didn't print it out. Mutable list. Run this, you would see you have a new element, which is 11 added to the list. Now you can't do this to your immutable list because that's the definition of an immutable list, right? You can't add in elements. Apologize for the background noise. Okay, but I'm gonna now show you another function that we have called mutable list dot add all. So say you already have an immutable list in your if created above, right? The numbers. So say you want to add all the elements of that list into this mutable list. So what you would do is mutable list dot add all, and then call it numbers, and you would run, and you would see. Oh, sorry, I didn't print it out. Again, if you ln list. If you run this, you would see you have all the elements of your first list added to this list. So that's a pretty useful function, I would say. Moving ahead, now is that we've added elements to the mutable list. Say you would like to remove elements. So you have a function, as you might have guessed, called mutable list dot remove to remove a particular element. Say I'm gonna remove 7. Then give me a second, please. Yeah, sorry. So say you would like to remove a particular element from your list. So after you've done that, we would just print the list to see what we have. Mutable list. And you would see that 7 has been removed from the list, right? Now this function that we saw, it removes a particular element that you might know that already exists in the list. But say you want to remove a particular index, remove an element from a particular index. So what you would do is dot remove at. So remove at, say you want to remove something at index 0. So that removes the element 5. So when you do this, you would see that the element 5 has been removed from our list, right? So that pretty much wraps up lists. There's a lot of Kotlin concepts going on at the moment, and I know it might all be a little too much to take in together, but all of this is going to be used in the courses that we're going to be covering today, tomorrow, and the after. So I guess please bear with me while we get the concepts done with. All right, so now moving on to what we call sets. Again, if you know Python, you would know what a set is. A set cannot have duplicate elements. So say you have a list with duplicate elements and you create a set out of it. So what would happen is all the duplicate elements would get removed, or yeah, that is the most important part about sets. So how you create a set is pretty similar to how you create a list. So say you call it a set, you set of 1, 2, 3, right? And you print and out, you would see you have a set, 3 elements created, right? Now, again, you have 2 different types of sets, which are similar to your lists. You have a mutable set and an immutable set. Again, immutable stating that you cannot change it once it's been created, and mutable stating that you can change it, you can add elements after it's been created, right? So again, you would create it in a similar fashion. Equal to mutable set of 4, 5, 6. Ln set 2, you would see again a set of mutable elements. Now again, you have the similar set of functions as you have for lists, so I won't be talking too much about those. Right? So that pretty much wraps up sets. Now we have something called dictionaries. Again, if you know Python, you would know what a dictionary is. It's a set of, not technically a set, but it is a key value pair based. I wouldn't call it data structure, but yeah. So you have a set of key values. So you have a key, and then you have a value for that particular key. So it's like creating maybe say, imagine as you have an array. So if you access like a of 0, so instead of that, what you would do here is a of key, and that would give you the specific value for that key, right? So again, dictionaries have a couple of advantages over arrays, right? So that again, the keys would be unique as you have it in arrays. So you have only one key pointing to a value, but the values can be duplicates. So I can have a of say the key being 1. So a of 1 can be say a value 2, and a of 2 can again be a value 2, but you can't have common keys. They are unique. So to create a dictionary, you also call dictionaries as maps in Kotlin. So the function does not go by dictionaries, it goes by maps. So again, creating all the functions have a pretty similar layout. So say you want to create dictionary equals to, then you have mutable and immutable. So I'm going to just show you one so that we can avoid repeating concepts. Mutable map of. Now I'm going to show you a little different version. I mean, not a version, but how you can also use the functions that we mentioned above. So you would see in the previous functions, we've just done set of or list of. We haven't specified what kind of values we would be, adding into the list of the set. So, I mean, again, that's not necessary, but if you would need to do it, what you would do is you would, again, see the function called mutable map of, and then in angular brackets, you would specify your key and value types. So I would say my key would be of type string, and my value would be of type int, right? So you can do this for the for list and set as well. You can add a key and a data type for what you're going to be passing into the function, right? And then say I have Android and do one, Kotlin do two. This is how you create a dictionary, what you call a map. So say you run this. Sorry, I didn't print it out again. My bad. In this, you would see that you have a key, Android equals to 1. That's how a dictionary is displayed. Say I want to access a specific element, what I would do is println dictionary of Android, right? So I guess that needs to be in quotes. Yep. So you would see that dictionary of Android, and that gives me the value of that specific key, right? So that's how dictionaries work. Pretty similar to how you see arrays, but yeah. Now again, you have the similar set of functions to add. I mean, the adding in elements function differs. So to add in elements to dictionary, you use a function called put dictionary dot put, and then you would say Java and zero, right? Println dictionary, and you would see that we have a new element added to the dictionary. Yeah. So that's the only function that differs, but the rest of the functions are pretty similar to what you saw before in lists and sets. Now that covers dictionaries, and the final data type we'll be talking about is int range, which I mentioned at the beginning. So int range is something that you use to create a range of integers, as it says. So say var a, we used a before, right? So let's say range, call it int range equals to 1, 10. So this is the range of integers from 1 to 10. So if I print this out, you would see that okay, that doesn't print out each and every element, but to print out each and every element, you would have to probably run a for loop. So if I do that, so you would see all the elements from 1 to 10 are printed. This is inclusive both 1 and 10, right? So these are going to be pretty useful in a case, for example, you're going to be building an app where you want to have multiple buttons. So you declare an int range, and you would run a for loop. And inside the for loop, what you would do, you would assign a button for each and every int range to be displayed. And you could use this, say, as a text on the button, something of that sort. So it's pretty useful again. Now, I'm not going to be talking too much about if else conditions, because they're pretty similar to what you have in other programming languages. Again, for loops, while, do while is again very similar. In fact, there's no difference. So I would be talking about those. You also have what you call you have functions, which again they're pretty similar to other languages, but the only thing is how you declare them. So you declare them using the keyword fun, fun, then you have a function name, say a, right? Now the function might or might not have parameters, right? But imagine we have parameters, so you would put them in a bracket right after your function. Say I have two parameters for this function. So one would be an integer, and another would be a string. So I would state them as, say, x integer, y string. So this is how you define parameters function. And say your function has a return value that you return to the calling code. So how you would do that is you would say this way, an integer. So this specifies that your function returns an integer. And then you would have your curly braces to indicate a block. And then inside your function, you can have as many lines of code as you wish. So say I'm going to type This is a function. And again, when we run the function, right? So we would have to provide, the parameter values. So if you can also declare default values for your parameters, just in case you forget to pass them. So say I say int equals to 2. This is the default value. String equals to Android, right? So let me print them out as well, right? So if I run the function, if I run the function, you should see, right, in a second. Okay, we need to have a return expression. I would remove this for now, but that is how you specify that you're going to have a return type. Right. A second. Okay, this is caps, sorry. So you would see that this is a function and Android has been printed and both the parameters have been printed. So that's how functions work. Again, you would be using functions and are going to be coming to classes. You're going to be using them extensively while you create Android apps. So this is, again, a pretty important part. Again, function names would typically not be so small, right? So you would have to use camel case again. That pretty much wraps up functions. You also have what you call lambda functions that are pretty similar to what you have in Python. Not going to go into too much details of that right now because it's being too much of Kotlin concepts, I understand. Also, as I mentioned, your loops are pretty similar to what you have in other languages, but notable difference, I would say, is you have a keyword called repeat that allows you to repeat a specific set of sentences, lines of code a particular number of times. Say if I do repeat 5, and then say 1. So this is going to repeat this particular line of code 5 times. And you would see, yep, it prints it 5 times. So that's something new that you all should know. Right, and then coming to the last Kotlin concept we would talk about is classes. Now, this is again a pretty big concept, so I would try to make it as concise as possible. Um, Again, if you know other programming languages, you would know what a class is. So we would declare this outside our main function. Again, you can have it inside your main function, but just for the sake of it. So naming convention again would be camel case, class test, example. Now, again, you might have parameters. Generally, you don't have parameters for the class, but Kotlin allows that as well, right? And then you also say inheriting from other classes. The concept of inheritance, I would be coming in a minute, but say inheriting from other classes, what you would do is put a colon and then mention the other class name, whatever it is after this. Right, similar way you did it in functions for the return type, you would mention a class name here from which you're inheriting. And then you would have your curly braces, and then you would have your set of statements that you would like to include inside your class. Now, a class can have what we call member variables and member functions. Member variables is something which typically are called variables of a class. So when you create an object, which is say a class can be referred to as a blueprint, and an object is what you create an instance of that class to use in your program. So you can use those variables and member functions via that object. So say I have a variable valley, val say test equals to 10, val string test equals to Android. And then say you have member function test, which does is it would just return test, right? And then this is a very basic class. You would, of course, use more complex classes in your programs that you write for your app. But that would be it for now. And then say I create an object of the class, which I said is an instance of the class that we create. So obj equals to test example. This is how you create an object of class. Now if I do println obj dot test and then obj dot str tst. That is how you access the member variables of a class via an object. So if you run this, I'm sorry, I seem to have messed up something. Second, please. Right, give me a second, please, while I figure out what I've missed. Okay, I'm going to be coming back to that in a second, sorry. But I'm going to be talking you through visibility modifiers of a class. So what you technically have in a class are these member variables and member functions. So you have different visibility modifiers that help you protect the data that you do not want to be shared to specific parts of the code, as well as share the data that you would like to. So by default, all the variables that you have in your class and your member functions are something that you call public, right? So as the term public states, you can use them in any part of your code, like provided wherever you create the object, right? And then you have a visibility modifier called private. So that means that you can only use those variables and member functions in specific parts of the code. So, which means that visible only inside the class. The variables should be visible only to the functions inside the class. Moving on to another visibility modifier called protected, which means that the member has same visibility as private, but as private variables could not be accessed anywhere outside the class, but protected variables can be accessed, in something that you call subclasses or classes that you inherit this particular class from. And again, public, as I already mentioned, would be visible to all other classes and all other parts of code where you create an object, right? And then the class that we created here, this is called a final class because you technically can't inherit from this class, right? To create a class that you can inherit from, you would have to use a prefix before the keyword class, which you call. Okay, before that, you have something called abstract classes, so which you build only so that you can inherit from that class and create different member functions. So say you have abstract class, you would need to use the keyword abstract, right? So abstract class is something that you create only to be inherited from. All member variables within an abstract class should be, declared with a prefix abstract. So what this does is it helps you in, now say you have another class called class B. So once you inherit from this class, you can access all these member functions and variables, but also say you wanna change these values to something of your own. So you can do that as well by something called overriding. Before I deep dive into that, I'm sorry, I didn't realize that I didn't put val. Right. So okay, I'll get back to that and apologize. All right, so so you have an abstract class, as I was talking about. and you have member variables this way, right? So as I mentioned, you create an abstract class only so that you can inherit, perform inheritance in this class, right? So now say I have another class called B. Now to perform inheritance, you would do it in this way. Test exam, and then you would have your member variables in this class. But to, as I mentioned, you have a concept called overriding. So say I want to change the value of this test variable to something else of my own in this class. So I would do val test equals to 20. So what this does is it helps me change the value of that particular variable in a different class as per my needs. So an abstract class is used only for inheritance, as I mentioned, but you can also have another keyword that you use to create classes from which you can inherit. So that wouldn't be necessary at the moment, but all you need to know is an abstract class and how it's used to inherit from. Now, that pretty much wraps up the most important Kotlin concepts, and you would use about most of this while you create and build apps. I've taken up a lot of time covering up Kotlin concepts, and it's been a lot to process in this amount of time. So I suggest we have a quick break for about 5 minutes, and then we can again continue with Android Studio and how you create your first app and all of that. So it's 7:02 right now. I would take in a little amount of time to answer to your questions while you all can go and have a break for 5 minutes. We would be starting at about 7:10, I guess. Yeah, that should be good enough, right? Right, welcome back, everybody. I hope you enjoyed the break. I mean, there's nothing really too much to enjoy because, yeah, COVID. But, right, getting back to it. Now, I looked up a couple of questions that all of you had asked. So, answering to the question Kotlin or Java, uh, I would definitely say Kotlin because, firstly, as I mentioned, it has a couple of advantages over Java, as I showed you in the slides in the beginning, right? And, null safety, and it's supported by Google, of course. It also gives you most of the features of Java, but it also adds on a lot more. And you're going to definitely have the support of Google, as I mentioned. So that's one of the bigger things. And again, it's I wouldn't say very, but it's relatively a lot easier to code in Kotlin rather than Java. And also, it's the official supported language for Android app development. So I would definitely say Java to that question. Moving on to the next question, are there any naming restrictions of variables in Kotlin? So, I mean, yes, you do have a couple of restrictions, but it's pretty similar to other languages. So if I list them out for you, you can start a variable name with a letter, an underscore, and then you can follow them up with numbers or letters. And of course, can't have white spaces. You can't have special characters, but you can of course have underscores. And they are case sensitive, which is pretty similar to other languages. You can't use keywords, and it's recommended to follow camel case. But again, of course, recommended, but it's up to you, right? So that I hope that answers your question. Moving on to the next one, is there a map function? Yep, that is true. I did not quite mention that because we were covering too many of Kotlin concepts without moving into Android. So, but yeah, there is a map function that is very similar to what you have in Python. You, in fact, even have a filter function, and you can use them together as you do in Python. So, yes, I hope that answers your question as well. Moving on to the next one. Uh, is necessary to follow camel case, you mean? Yes, as I mentioned, it's very advisable to do that because that would follow a standard set of procedures, or I would say protocols that are advised by the Kotlin documentation, if you would look into that. But yes, that would be the answer to your question. And calling an object, do you not need curly braces by calling an object? Answering that question, yes. I mean, uh, uh, I guess what you're trying to ask is, while you create an object, what you do is var object equals to class name, and after that you have curly braces, and then you have your object name dot your object property, which can either be your say a member variable or a member function. So I think that should answer your question. And yeah, I apologize. I took up a lot of time covering Kotlin concepts. So the session is going to extend a little bit more. I won't be able to finish what I had planned for the entire day today, but I'll make sure I cover them up tomorrow in tomorrow's session. Right. So now I would get back to the presentation. All right. So, yep, we are done with the break. And then, yes. Now we're going to be covering Android basics. So Android Studio is the official IDE, or what do you call an integrated development environment for developing Android apps. This is a partnership between IntelliJ and Google. That's the company that built the IDE called IntelliJ IDEA, which was used before this, but now it's completely moved on to Android Studio. You have a lot of tools which can help you develop applications, right? So I'm going to be talking about the entire project structure as you see here in a couple of minutes. And then you also have something called an Android virtual device. which helps you emulate an Android device on your system. So what this does is it uses your system's virtual machine capabilities. If you're running Windows, it might be called Hyper-V or virtual machine platform. You might want to have that enabled if you want to run Android virtual devices. So what this does is it emulates a phone on your laptop, and that helps you test your Android apps. You can of course choose different phones from a set of list of devices they have, and not only phones, right? You can also build apps for Android Wear devices, which are your smartwatches. You can build apps for TVs. You can build apps for what do you call Android Auto, which is your interface for vehicles, where you run Android on your infotainment screen. So you have various different options to create an Android virtual device, right? Now I'm going to be opening up Android Studio and guiding all of you through a structure. So that's pretty important. Right, so you all can open up Android Studio later. I would just explain you the entire structure at the moment, and that would help you. Right. So once you open up Android Studio, depending on whether you're running it for the first time or you have a few projects set up, it's going to look like this. In my case, I have a few projects, right? So that's the set of projects I have. Now, when you click on customize, it lets you choose your theme, font size, pretty standard settings. Plugins lets you install, plugins that help you code faster, better, and easier. And here are a few links that guide you to the same set of websites that we're facilitating content from. So say you want to create a new project, you would hit on new project. Now this loads up a couple of what we call activities. So what an activity is what you see on your phone screen, right? So when you open up an app, imagine you're opening up, say, Instagram, right? So the screen that opens up on your app, that is called an activity. It can also be called a fragment based on if you're creating an activity or a fragment. But in general terms, you would refer to it as an activity, right? You have different types of activities here. They give you a set of pre-defined or pre-built codes that you can use to develop your apps, right? So you would see a lot of different options, right? So we would, of course, start with an empty activity. Coming to that in a second. Now, that was for phone and tablet, as I mentioned, for different devices. This is for your smartwatches. Now, you also have it for your TV, as I mentioned, and you also have it for your automotive, which is your Android Auto. So you can start off with your basic layout as those. Now, I would go back to phone and tablet and start with an empty activity, right? So now once you select an empty activity, you name your app, right? I mean, this is not the name of your app. I would say you can change it out later. But yeah, so say I call it Android Study Jam Session. Okay, just an Android Study Jams as one. Now, package name is something you wouldn't need to worry about right now, but what packages are they create different, different structures for different parts of your code. So say one part of your code displays the UI or a user interface. That can be one part of a package. Another package could be something that connects to the internet and loads data from there. Another package can be something that connects to your database and stores or loads data from there. So, right, you can have multiple packages, but a package name right now shouldn't bother you. Your save location is where you would want to save an Android project. And now language, of course, we're going to be sticking to Kotlin, right? And your minimum SDK. So this is going to be something you might want to keep in mind. So as you see a prompt here that your app will run on approximately 98% of devices. So when you build an app, it's up to you to how you want to, what do you call it, support for multiple devices. But it's more appreciated if your apps can run on most of the devices than run on the latest ones, right? Because everybody won't have the same set of phones. So you might want to stick up to Lollipop, but again, you can select different versions, and you would see that it increases, right? So, but we would stick to Lollipop, which is 98% of devices. Now, we would not select this checkbox because legacy Android support libraries is something that was used in the past. Now, this has been replaced by something we call Android Jetpack. Android Jetpack is a library that is used for various purposes in Android app development. Library, as you would know, is a set of tools that help you, develop a certain set of actions faster. Moving ahead, once you hit on finish, this is going to be what you see, right? So it's going to take a little time while it builds up your so-called Gradle file. You would see Gradle projects and in process. I would explain everything about the entire app structure in a second. You might want to give it a little time while it sets it up, right? It's going to take a little bit of a time, so please bear with me. Now, again, if your device does not have enough resources, you might want to stick in with an external Android device. But if you think you have enough resources, so you can run an Android virtual device. But again, running both together is pretty heavy, so I would suggest you to, run an Android device separately. But again, totally up to you. Right. So now you see the entire app has loaded. We select an empty activity. So that's what this is. We don't have anything. So this is your project structure at the moment, right? You would see on the left-hand side, you would see what we call a project structure, where you have different sets of folders. This is the app view. This is what you'll be concerned about most. The rest of the views, this is the Android view, right? You have different sets of views here. And I think the others won't be necessary for you to understand at this point. But yeah, this is what you would be interacting with most of the time. So this is your project structure view. Again, you see if you click on this and gets disabled. Again, you have a resource manager. Resource manager is something where you can add, say, images, SVGs. SVG is something called a scalable vector graphic, which lets you add, say, images which can be scaled according to the size of your device. So here you can add in resources. And then this is again your structure in a more defined way, right? You also have favorites that you might add, and you have your build variants, which should not concern you too much at the moment. So you might want to stick onto project view here. Now on this side, you have your Gradle, which is again, I would show you in a minute. You again have your emulator, which is again present here as well, which I would show you. And on the bottom, what should concern you is your logcat, which we would use to, debug our app in a simpler way than the extensive debugger that's present along with Android Studio. Logcat is basically, to display logs about what processes are happening and how and when are they taking place to find out errors, all of that. Build shows your details regarding to each and every build, be it the Gradle build, be it your apps unbuild, all of that. Terminal, again, pretty similar to what you have in most IDEs. Problems show errors, and to do would be, it shouldn't bother you at the moment, right? Okay, now moving on to the top, you have a standard set of options in the menu bar. Right, you would see option to create. This is pretty normal stuff, so I wouldn't talk too much about it. But what you should know is in the build options, in the build menu, you would have an option to create an APK for your app, right? So that you can allow it to be shared on Play Store and allow other users to download the app. I would be showing that to you probably in tomorrow's session. And also, this is the run menu, and that gives you access to the debugger, which we would not be using because we're going to be running a debugger in a simpler way. Now, tools gives you access to what we call the AVD manager, which is pretty cool. I mean, when I installed Android Studio for the first time, the only thing I knew was it was pretty cool to run a phone on your device. So if you click on AVD Manager, I have Android virtual device setup, but if you don't, it gives you an option to just create your Android virtual device, right? So say we're going to be creating a device, so you click on create virtual device, gives you the category of devices you want to choose, gives you the name of the device. All are pixels or nexuses because that's probably what Google phones are. And you have a couple of standard screen sizes for foldable phones and all of that, right? But we want to stick out to the pixels because they support it better. So select any device you would from the list, and then you want to click on next. You want to decide on which API level. So you might not want to look too much into this, but you would see here, right? So which version of Android you want to run on that specific virtual device. So I have Android R downloaded, so I would create a virtual device with that. And once you click on next, that creates a virtual device. So that would take a little bit of a time, hence I wouldn't be doing it. I'm just going to run the virtual device I have. So once you click on that button, it's going to take a little bit to load your Android virtual device. And as you see, in a second, yep, so that's your virtual device running on your system. Yeah. Yep, so that's what it looks like. It's pretty similar to a phone, right? You have all kinds of options. You can change the orientation. See here, you can rotate the device based on how you'd like it to be. You can increase, decrease sound. You can power off the device. You can turn on a camera. Of course, it does not turn on a camera, but simulates that. You have your navigation buttons, which work here as well. And then when you click on this, you have a series of options. So again, location, yeah, battery level, these all help in testing out your device. So say the first app that I built was something to do with sensors, right? So you want to test out your inclination or your accelerometer. So you can rotate the device this way and you would see your sensor values changing here, which help you determining if your phone, if your app is working properly or not. And again, record what's, running on a device and all of that. That's pretty cool, right? Now, that should be covering Android virtual devices. Now, coming to the most important part is your project structure. Right, so this is your manifest. Everything is grouped into folders to help you navigate easily, right? The first folder you see is your manifest. Now you would see here what we call a manifest file, right? Again, the list of files you have open opens up here. So a manifest file is something to do with your application setup, right? You have your application, all details about your application that needs to be present in an app is present in the manifest. This is again done automatically by Android Studio. You have your application name, you have your application icon, you have your theme that you have set for the entire application. Now, when your application opens up, you have the page that shows up in the beginning. And then this again, activity is what I mentioned at the beginning, right? There's a set of screens that you see in your app. And again, so that's basically what a manifest file is, right? All the details you would necessarily need about an app and it installs on your device. Moving on to I would close both of these. Moving on to the Java folder, where you have the first folder, which contains all your Kotlin files that you would, be present in your app. This is basically called the business logic because this is what you write, right? The logic that you build in your app, everything is written here. This is where you code the backend logic for your app. Now, backend technically does not mean the backend that you have, say, in websites, but this is basically the logic for your app, right? The next two folders that you have are test folders. So when your app is small, you wouldn't see a need to run tests because you can manually test out the app, right? You can just click around and see if it's working fine. But when your app scales up, you might want to have to write tests for your app so that you can test out most of the functionalities of your app without having to manually do everything. Of course, manual test is still needed because you want to know how a real user uses the app, right? So this is an example of an instrumented test. An instrumented test is used to test out an entire app, right? So this runs on an Android virtual device. Whereas a unit test is used to test out a particular function in your app. So if you see addition is correct, what this does is, this is the example, right? So it basically tests a specific function and tests this 2 plus 2 is equal to 4 if you run this. So you can run it by clicking on this specific button. If you run it, you would see that 2 plus 2 equals to 4. So that would say that your test has passed, and it's going to take a little bit of a while, I suppose. So I'll come back to the result when it loads in. Now, another important part of your Android Studio for app structure would be your resources folder. This is something, okay, before I go on, you see tests passed, right? So this runs on something you call a JVM, which is your Java Virtual Manager. Java Virtual Machine. You would see the unit test is run, whereas for an instrumented test, you would have to run it on your virtual device or your Android device, whatever be it. Now, moving on to the resources folder, you would see you have something called drawable, which basically it adds in your icons part of the app, right? So every icon has a background and a foreground, and what you see here is XML code. XML is a format that's used widely throughout Android Studio for different layouts that you create throughout your app. Now, as you see a layout, I'm going to talk about all of this in detail probably in tomorrow's session, but a layout is something that you would see on your screen. As I named an activity, of course, you call this an activity, but the structure of your activity is represented through a layout, right? So you have different elements in the layout that you call views. So you have text views, button views. I'll be discussing this in tomorrow's session in a much broader aspect, but just to show you for the moment. So you just drag and drop here, right? That's how you add views to your layout. And similarly, you have images, you have buttons, you have toggle switches, all of that, right? This is what you would be seeing on your Android app when you run it. Not too much to be worried about at the moment. I'm just doing something so that I can show all of you what it looks like on your device. Now you have map. Map maps are basically your icons so that they can be rendered on different pixel density screens. So you might see that depending on what type of screen you have on your Android device, be it OLED or LCD, just you have different densities of pixels from different types of screens. The denser the pixel density is, the higher the pixel density is, the better your screen would look, and therefore you would have to have different icons for different pixel densities. You would see this is just a set of icons. In the bracket for each icon name, you would see the pixel quality defined: HD, pixel intensity, medium, ultra HD, all of that, right? Now this is again, as you see, icons have different shapes on your devices. So to make sure you have those, these are your round set of icons. Then your value is an important part of your Android app again, because this is what you use to say if you want to display a particular string, what you would do is you would go to the strings.xml, you would define a string here so that you see an app name, right? So you would just define a string in a similar fashion. When you want to use the string anywhere on your app, you would just call this name of the string, right, instead of hard coding, because that would help in translations, talk back, right? Similarly, for colors, you would name color according to your choice and then provide the hex code for the color. I will be talking about this again tomorrow. So you can use the color name instead of using the color directly. That helps you, make it simpler for you to use it in multiple parts of the code rather than define it again and again. Finally, coming to the last two important parts of your Android structure, Android app structure. This is something called your build.gradle file. You would have seen in the beginning it said Gradle sync in progress. So this is basically configurations for your app, right? So you have two Gradle files. One is your app level Gradle file and one is your code level Gradle file. This is the code level. So here you might see in the commands, you don't add your application dependencies here. This is just to add dependencies for your other Gradle file to run, right? Whereas when you go into the app level Gradle file, you would see your default SDK version. You would see different configurations for your app. Minimum SDK target is the same as your compile. It might differ, but yeah, generally it's kept the same. And then again, whatever dependencies, like say you want to include different libraries, you have to import them in your Kotlin file as well as you would import them here. So that's basically your Android Studio app structure. I know I've taken a large amount of time, so I would continue with the rest of the concepts tomorrow. As you all know what the basic structure of an Android app is, you all could explore on your own, just to figure out what is what. Don't mess around with the settings unless you know what is what, but totally up to you. And also, tomorrow we will be starting off with building your first app. That would be pretty simple, but it would be running on your device. Followed by, I would show you a set of sample apps that Google has provided us with. And I would show you how you test and debug in a simpler way, followed by something you call material design, which helps you design your apps in a better way. And then throughout the series of the next two sessions, what we would do is we would learn a specific concept and we would implement it to our app. So that's how we're going to be proceeding. Right. So I hope all of you had good enough time learning. I mean, I know I've taken a little bit of an extra time, but yeah, I mean, if you all have any questions, please shoot them. Also, feel free to reach out to us on our Discord channel that was provided to all of you, I believe. If you have any further questions during the course, I'll wait for a couple of minutes if you have any questions. If not, thank you all very much for listening. Thank you, Aditya. Thank you for listening. Great. Any questions, feel free to ask at any point of time. I'm not sure if that's your real name, but thank you again. Thank you for listening. I mean, that's not your real name again. Okay. Thank you, everybody. It was great having all of you here. It would have been better if you could have done it, in person, but of course, have to stay at home. Anyways, thank you, everybody. Thank you again. Thanks, Jitesh. Thank you, Shruti. Thank you, Sajanya. Great having all of you. All right. Catch you guys in the next session. Thank you.